Your task for this project is going to be to come up with the parametric equations or a pair of parametric equations for each of several graphs. By way of explaining how we're going to do this, I'm going to do one for you here on the screen, and then this is actually the answer to the question in this tutorial. Once we've worked through this one together, you'll have a pair of parametric equations that you can enter on the next page in the assignment. The idea of pages hopefully will become clear as you work through the assignment, but we'll work through this example together, and then when you go to the next page in the assignment, you will be able to enter the answers I give you here at the end of this video, and you'll be able to use that then to see how to enter your answers and what it does to the graph, what it does to the rendering of the graph of the parametric equations. So let's go ahead and get started. Let me show you the graph we're going to be working with for this particular problem. We have a graph, but no equations, and our job is to come up with equations. Now, in the previous example, we had just a circle, and I said, imagine you're starting here. What is the x coordinate doing? And for the circle, it was just coming from x equals 10 down to x equals 0, and then down to x equals negative 10, and then down to, back up rather, to 0, because I'm thinking in this direction. From x equals 10, it went back up to 0, and then up to positive 10. So that was what x was doing. What is x doing now, though? Well, it starts at 10, and it comes down until it gets to about 2.5. It's to about there. But then it goes up again. If I trace this curve along here, it comes down to here in terms of x, and then it goes back up. So it comes down to 2.5, and then it goes up to, looks like about 5.5. But then it starts to come down again, and it comes down until it gets all the way down to negative 5.5. It comes up again. So if you were standing up here looking down, all you would see would be that x was at 10, x came to 2.5, x came to 5.5, x went to negative 5.5, x is at negative 2.5, x is at negative 10, and now I'm down here, and then x is at negative 5.5, negative 2.5, negative 5.5, 5.5, 2.5, 10. So I've come all the way around the circle, all the way around the curve. Now the question is, how do we track that? How do we record that? I'm actually going to move my graph to the other side of the screen here. I'm not sure why, but for some reason I like to have my mini graphs on the right-hand side of the screen. So I'll put those in place and recognize that this first one is going to be x in terms of t, and the second one is y in terms of t. And then the other thing I'll do is remembering that even for a circle, I needed 2 pi to get all the way around the circle. I know that I'm going to need 0 to 2 pi to do this work. So I'm going to make sure that my 2 pi labels more or less line up on the two graphs that I've got going on here. So now I'm kind of set up and ready to go. What I'm going to do next is pick a point to start. And in this case, I'm going to start here. I tend to start, if I have a nice symmetrical graph, which I don't always, I tend to start at, I'm just going to say c, 0, because it could be any of these values. So in this case, what I've done is I've chosen an extreme value for x, where y is 0. So I have the point, in this case, 10, 0. All right. You could equally just as effectively start here at 0, 10, or here at negative 10, 0, or down here at 0, negative 10, or for that matter, you could start anywhere you wanted, absolutely anywhere. There is no legal reason, there's no technological reason, there's no theoretical reason for starting in a particular place except experience. And I would say that while it's legitimate to start in any of these other places, starting at some extreme value is usually a good bet. That's a good safe practice. This is my favorite, and I also usually, once I start imagining my point moving, I imagine it moving counterclockwise. So if I were this point and I was walking on this curve, my left shoulder would be inside the curve. Okay, so that's kind of a personal preference thing. That's where I'm going to be starting. It's important to establish where you're going to start because you need to start in the same place and move in the same direction for both your x of t and y of t graphs. Now that I've got that though, let's take a look again and imagine that this point that I've plotted here is moving along this curve. And remember what it was I was talking about a minute ago about watching it from above and only being able to see it moving from 10 down to 2.5, up to 5.5, down to negative 5.5, up to 2.5, down to negative 10, and so on. And I'm going to start trying to record that. So I know that I'm going to need to go up to 10 because x goes to 10 and x goes down as far as negative 10. So I'll label my graph accordingly. As it happens, so does y. Y has the same extreme values, 10 and negative 10. So when I get there, my y graph will go up as far as, I'll do it over here, up as far as 10, and it comes down and up and down and up and down. It only gets down to negative 10. So those are the most extreme values. I know I'll be able to graph the whole thing within that range of values. All right. Now, again, I'm starting at x equals 10 when t equals 0. So at the point in time when t equals 0, over here, this is when t equals 2 pi. We're assuming that it's, let's say we're in seconds here, we're assuming it's going to take 2 pi seconds to go all the way around. That's just because it's a convenient number of units, because we know we need to go 2 pi to begin with, right? So we'll just start by saying we're going to go from 0 to 2 pi. So my point is starting here, and in terms of x, it's at 10. So I'll record the point 0, 10. T is 0, x is 10. After a little while, it starts to move down because I'm thinking in terms of x. What's happening to the x coordinate here? It's getting smaller and smaller and smaller. And it gets smaller, but it only gets smaller to a certain point. It only gets down to about 2.5. All right, so let's put some halfway marks in here. There's 5. That means 2.5 is about there. So after some time, my point is at x equals 2.5. After some more time, it comes back up to 5.5. So after some more time, x's value is now 5.5. Okay, what happens next? X starts to go back down again from this extreme x value here. It starts to go down again, and it keeps going down. It goes through x equals 0. This is where x equals 0. So it will go through x equals 0 to x equals negative 5.5. So it's going to drop all the way down to about here. Right, so now I'm here, and I'm just going around the curve. I got to here. Now I'm going to keep tracing. Now the x value is going up again. It's increasing. It's going up, and it gets to negative 2.5. So it comes up to about here. So now I'm here. Let's see, what have I done so far? 10, 2.5, 5.5, 0, negative 5.5, x is negative 2.5. Then x starts to go down again, and it goes all the way down to negative 10. I'm going to get to here. And each one of these is starting at t equals 0. Some time has passed, some more time has passed, some more time, some more time, some more time, and some more time. And right now, I'm down here at x equals negative 10. X equals negative 10. That point looks like it's just a little bit too low. There. All right, so I made it to here. I need to keep going. X now starts going higher than negative 10. It starts coming back up this way. So I get up to negative 5.5. Let's plot that one. And then it goes back down to negative 2.5 first. Negative 2.5 and then negative 5.5. To erase that point. I'm coming up to negative 2.5 and then negative 5.5. Okay, how far have I gotten? 2.5, negative 5.5. Then it comes through 0 again. This is where x equals 0. and it comes up to 5.5. So I'll come through 0 and I'll get up to 5.5. So now I'm here, I'm just looking at the x value. X is 5.5, then x drops to 2.5. So I have another 2.5. Okay, and let's see, where am I? Where am I? 5.5, 2.5, I was here, looking at that x value, and then x goes up again, so it goes up to, and it gets all the way up to 10. So by the time I'm done, I've hit all of those kind of extreme points. Each one of these is kind of an extreme value point for x. It's kind of a turning point, right? X started at a maximum of 10, it came down until it got to 2.5, and then it stopped coming down and started going up. So this is kind of a turning point for x. Now, I didn't quite make it all the way to my 2 pi mark, but I've made a full cycle. So in the future, I'm not going to make this 2 pi mark before I start because I won't really know. I'm just kind of eyeballing it here, and I'm not really actually sure how long it's going to take me to graph enough points to get the full picture. So in this case, I stuck a 2 pi there thinking that I would take about that much space to get there, and I didn't quite need that much space. So rather than move all my points, I've just moved my 2 pi, right? That's how many points I had to plot to make a full cycle. Now, if you squint and kind of look at this sideways, I wonder if you can see kind of a cosine graph. If you follow along in between those points, there's kind of a cosine graph going on. So what I'm going to do now is connect the dots, but I have to connect them in order. So I'm going to come down to 2.5 and then up to 5.5, and then down through 0 all the way down to negative 5.5, and then up to negative 2.5, and then down to negative 10, up to negative 2. So I'm just connecting these in the order that I plotted them. I'm having trouble with this piece. These graphs really don't have to be pretty. I would encourage you to take enough time to make sure that they're relatively accurate. One thing to notice here is that I had points, and I know this pattern is going to happen, so I was watching out for it. But I have a point here at 2.5, another one over here at 2.5. So when I plotted this one here, I made sure it lined up with this one. I didn't tell you I was doing that at the time, but that's what I was doing. Same thing down here. Same thing here. And here. There were actually several places, right? So now what? Well, now I have a wiggly graph that doesn't really look like a cosine. It kind of looks like a cosine. It turns out that it's a cosine plus something else. So what we're going to do next is we're going to try to figure out what an average value is for this graph. And by average, I mean, what is the difference between this high point and this low point, right? This is a maximum value, a local maximum value. This is a local minimum value. As it happens, this one's at 5.5 and this one's at negative 5.5. So the average of those two is going to be 0. And I'll have another average of 0 over here. Now, I wasn't quite as accurate here. It looks more like the point should be here, but in fact, I know this value to be 5.5 and this one to be negative 5.5. So I actually know my average is there. And by average, what we're really saying is take the high and the low and add them together and then divide it by 2, right? Find kind of a midpoint almost. Well, that's really exactly what we're doing. If I take, for example, let's see, these 2 points right here, this one's 2.5 and this one's 5.5. If I add those together, I get 8. Half of 8 is 4, which is right in between these two. So I really am looking for the midpoint of that stretch. The midpoint between these 2 points, a low and a high and a low and a high, that one's going to be there. Just find the midpoint on each segment. Okay? Now here, we have to be careful on the ends. This one's not too bad. You can see that this is a high, this is a low, this is a high, and if I were to do a second cycle, I'd be starting back at 10 and coming down. So this really is a low and this really is a high. So I can just go ahead and stick my midpoint in there. There are times when it's not as obvious, it's not as clear that that's the case, and I'll cross that bridge when I come to it, but just be careful on the ends, right? Notice that I did all of these other points first, and then I checked my ends last. All right, now I have my average points. So let's connect the dots. I'm going to start inside. I'm not going to start right at the axis, but I'll come back to the axis and fill that in as well. I'm just connecting the dots there. Now I've left the endpoints. The endpoints are on the graph, but I haven't connected them to anything else. The thing is, if I were to do this cycle again, right? If I were going to repeat the white graph, I would be like going around a second time. Then my next low point would be down here, and I'd have another average point right here. So although I'm stopping at 2 pi, this graph goes all the way to 2 pi. Same thing on the other side. Okay? Now, what does that graph look like? That graph to me looks like a cosine graph, and it looks like it has an amplitude of about 6. So let's put 6 in there. And so far, I'm going to say it kind of looks like I have x equals 6 times the cosine of t. Well, that's great and everything, but that's not the graph I was looking for. That's kind of a starter graph. If you looked, remember before I plotted those points, I asked you to kind of squint and look through the white points to see a cosine graph. You could see a cosine graph. I don't know, some people have an easier time visualizing that than others, but I can kind of see a cosine graph in the white space between the points before you graph the wiggly line. But the graph that I want the equation for is this wiggly graph. So now I have to figure out, if I start with the pink graph, what can I do to the pink graph to end up with the wiggly graph, the white graph? And the way I like to do this is to imagine that I've got a piece of string in my hands. I've got the left hand side of the string in my left hand. That's the pink line here. The left hand end in my left hand, and the right hand end in my right hand. And right now, it's just hanging loose, right? But what if I take that string and pull it taut, make it a straight line? Now I'm comparing what the white graph looks like to the pink graph, but I'm doing it not on this bent, curved pink string, but on this straight one. So what I'm going to do now, this process is not necessarily quite this tedious. Once you've done a few of these, it gets easier. It gets easier to visualize what's happening. And I'll do, beyond this example, I'll do probably at least one other example in which I show you how I actually process this a lot more quickly. But if you've never done them before, I think it's helpful to see sort of what the idea is based on. So now at t equals 0, so I'm starting right here and put a tick mark there so you can see what I'm getting at, and I'll be ending here. At t equals 0, the pink graph is at 5 point. We decided that was 6, right? But the white graph is at 10. So if I had to graph this white graph over this pink line, I'd have to say, well, that's 10, and this is only 6. So that means that my white graph, in comparison to my pink graph, my white graph is 4 above the pink line, right? So I've kind of not left myself very much room here, but we'll say that that is 4. So it's like I have a white graph point 4 above my, well, that's exactly what it is, 4 above my pink graph line. So that's that point there, and it corresponds to this point on the white graph and this point on the pink graph. If I go to the next place along on the white graph where I plotted a point, right, wherever that is, let me put a mark on the axis on the pink line so that it matches. And then remembering that this pink curve is kind of like my baseline, I'm kind of treating it like an axis. I'm going to do what I just did for this point right here, but I'm going to do that for all of my white points. I'm going to ask myself, how far above the pink line is this point? How far below the pink line is this point? How far above is this one? And this one's below. How far is this one above? How far is this one below? And so on. But one of the things that I can do is I can look at the points in between as well and say, how far above the pink line is the white line here? The answer is 0. So in between, I have a point at 0, 4, and then I have a point here on the axis, on the pink axis that is a straightened out cosine curve. Okay. Now, what about the next the next point here? Well, that point is a certain distance below the pink curve, the pink line, and it's kind of hard to tell. This looks like we decided this was about 6. It might be closer to 7 actually, but let's just stick with 6 for now. We know this is at 2.5, so that means that I'm 3.5 below the pink line. Well, as it turns out, when we do this is all hand drawn, it's a very rough sketch. It turns out that when we do this, we're going to find that the amounts above and below are going to be the same. So although it looks like about 3.5, it's probably closer to 4. So that means that I'm going to have a point 4 units below the pink line. I should probably put an axis in here. This one here is for t equals 0. And then this axis, this is a height of 4, and this has a height of -4 here. All right, so I have a point when t equals 0 that's 4 units above the pink line, 4 units above the pink line. Then here where it's not above the pink line at all, they intersect, so the distance between them is 0. Then the distance between the pink line and the white line is -4. Then it's 0 again, and then it's +4 and 0 and -4, and so that just keeps going. So I have 0, and then actually let me see if I can line that up a little bit better. What I'm doing right now, I looked at this point, which is 4 units below. Now I'm going to look at this point, which is 0 units above or below the pink line. That is going to be, I think it's okay, I'll just put it there, 0. Then the next one is 4 units above. That's going to come up here again. And then the next one is 0, and then -4, and then 0, and +4, and minus, right? Keeps going. So I have 0, and then -4, and then 0, and then +4, and then 0, and then -4, and so on. But now I got to figure out how many times that happens. It looks like I'm starting above and going below and coming back up, and then below and coming back up, that's twice. Down and up, that's 3 times. Down and up, that's 4 times. That's 5 times. So I have from here 1, 2, 3. I need to come up here to get a 4th one. And then another full cycle. Now I haven't quite matched my period, right? This line here is 4 units above. It should be over here. But I'm not going to correct it because I don't want to take the time to do that. When I connect these, what do I get? I get a cosine curve. But in the same amount of time as it normally takes me to do a single cosine curve, I have 1 cosine curve, 2 cosine curves, 3 cosine curves, 4 cosine curves, 5 cosine curves. So the equation of this graph is 4, because that's the amplitude, times the cosine of something, where the something is between 0 and 2 pi. Normally I have 1, and now I have 5. So that's what that number does, right? That tells me the argument is 5t. But what have I done here? What does this graph represent? It represents the amount I've had to add and subtract and add and subtract and add and subtract to the pink line. Well, the pink line is 6 times the cosine of t. So that means the equation for x for this graph is x equals 6 times the cosine of t, which is my base graph, plus the graph I've added on to that, which is 4 times the cosine of 5t. That's pretty complicated, but it's a very predictable pattern. Once you've done it a few times, it'll get easier. So now what we've done is found the equation, or an equation. It may not be absolutely correct, but we'll have to address that separately. There's a certain amount of, this is all hand drawn again. There's a certain amount of guesswork. Is that really 6 or is it 7? Is this really 4 or is it 3.5? Right, so we'll come back to that. We'll address that in a few minutes. But now I have an equation for the x the parametric equation for x, I need a matching one for y. So I need to repeat this process and this process for the y coordinate. So I'm going to be starting with my point here again. It's like I'm completely starting over, except that instead of looking at movement in the x direction, I'm going to be looking at movement in the y direction. Okay, starting here and moving in this direction. The first thing I notice is that the y value there is 0. Let me put some intermediate values in here. I know I'm going to need them. My y value is 0 here. When I move along the curve, eventually it gets to about 5.5. So starting at 0 and moving to 5.5. Well, once it gets up to 5.5, it comes back down to 2.5. So we're going to get down to about there. And now I'm here and I'm going up. I'm going to go all the way up to 10. And my y value there comes down to 2.5, then up to 5.5. So down to 2.5 again and up to 5.5. So now I'm here. Now it's going to come down through 0 on its way down to negative 5.5. So it will cross through the x-axis, or the t-axis rather, on its way down to, what did I say, negative 5.5, right about there. So now I'm down here, then I have negative 2.5. I'm looking at the y value this time. Negative 5.5, negative 2.5, negative 10. I had my negative 5.5 there, so I'm going to add negative 2.5, and then negative 10. Now this time I have, my thing's going to be too big. I haven't given myself enough space. That's okay. So I got down to negative 10, but now I need to go back up the other way. So I have negative 10, then I'm going to come up to negative 2.5, negative 5.5, negative 2.5, negative 5.5. Maybe I will have enough room. And then up to 10, up to 0, to y equals 0. So I'm there. Now this time, I kind of did the same thing actually. My 2 pi is not quite in the right place. I need to move it over. You will find when you do these that it ultimately doesn't matter if these graphs really line up perfectly. But if you get used to working with them in sort of relatively the same amount of space, it would be very helpful. All right, so now I'm going to connect these dots. Remember that this time I started down here at 0. So I'm going to go, before I do that, actually, let me see if I can point out what I see here. If I look at the space between the dots, I see a sine curve. Look at the space in between the dots. They call that white space in media, okay? Or what do they call it? White space. In media, it's called white space. In art, it's called, I think it's called white space in art as well. Anyway, I digress. I'm going to connect these points, and I'm starting at 0, coming up, and then down, and then up, and then down. And that point's not quite in the right place, but that's okay. This is a tool. It does not have to be perfect. It's helpful if it's somewhat carefully thought through and drawn out. Now, because my points aren't evenly spaced, my graph here is a little bit asymmetrical. It should be more symmetrical than that. But I think it'll be okay. So I'm going to use a green pen this time just so we can distinguish the x from the y. And I'm going to go back in and I'm going to do what I did next for my x graph, which was to find the midpoints. Again, I'm going to leave the ones on the ends here to last. The rest of them, I can pretty much just go in and find the point that's about halfway between the high and the low for that particular segment. It's helpful really to think about these because this one, for example, is easy to find because I know this was positive 5.5 and this was negative 5.5, so this one must be 0. Now on the ends this time, I do have to be quite careful because I'll use the right-hand end to start with because I have less space to draw on the left. If I were to start a second cycle of this, I'd be going up and then down and up, right? In fact, let me draw that in kind of as a dotted line. It would come up to 5.5 and down to 2.5, right? It would do something like that. So in this case, my midpoint is not here. Let me put that in like this. It looks like a midpoint should be there. But in fact, the next low to high stretch goes from negative 5.5 to positive 5.5. So my midpoint is actually right here, right there. And the same is true on the other side. On the other side, I'd be graphing something like that. So my midpoint is not here, but halfway between this high and this low, which is right there. I have a midpoint right there. And that's important because we're going to connect these dots now. And if I connect them starting from the wrong place, I start from here, then my graph won't work. And sometimes it makes you think you have a sine when you actually have a cosine, or vice versa. So it's really very important. All right, let's connect the dots. I have something that kind of looks like this. Again, it doesn't have to be perfect, but a little bit of care and caution in drawing it out is very, very helpful in the end. Well, that clearly looks like a sine to me. So let's say that that is y equals, what's the amplitude? Hard to tell, but it's going to be a sine. There's only one cycle, so it's the sine of t. I would say that that amplitude looks like maybe 7. Let's call it 7. I will say this, that because my movement in the x direction is, apart from a shift, exactly the same as it is in the y direction. In the x direction, I went from down to from 10 to 2 to 5 to negative 5 to negative 2 to negative 10, and then back again. In the y direction, if I started at the top, I'd have 10 to 2 to 5 to negative 5 to 2 to negative 2 to 10 to negative 10. Exactly the same motion. I started in the wrong place there on purpose because I wanted to highlight that was what's happening. But because of that, it's likely that the 6 right here and the 7 right here will be the same number when I'm done. It's a factor of having graphed this by hand that I can't really tell whether that's 6 or 7. So I'm just going to leave that for right now because it's going to instruct what you do once you get the two equations and try to figure out whether they're the equations of this graph or not. Having one of them, at least one of them, that's not quite right, will be very illustrative, and I think it'll be very helpful. Okay, now the next thing I'm going to do is take this string that it currently looks like I'm using as a kind of funky jump rope and pull it taut. Except I'm not actually going to do that this time. I'm going to do it on the graph itself. So I'm going to invite you to pretend with me that this curve has been pulled into a straight line the way I did here. So instead of letting this jump rope hang down, I pulled either end so that it became a straight line. Just imagine that that's what we're doing here. Then I can say that what I have, what the white curve is, when I compare it to the baseline curve of my green one, is that looks to me like a sine curve. Let's investigate that a little bit. I have, first of all, I'm starting at 0 on my green graph. And then the question I need to ask myself is, how far above the green graph is the white graph? And the answer is 0. Actually, you know what? I think I am going to do this. How far above the green graph is the white graph? And the answer is, at this point, 0. And then I move along a little bit and I say, how far above the green graph is the white graph? And the answer is, maybe 2. Call that 2. And then here it's 0. And here, how far above the white graph is the green graph? Well, it's not, it's below. Sorry, how far above the green graph is the white graph? It's not, it's below. So how far above is it? Negative 2. How far above is it? 2, 0, negative 2, 0, and so on. So here I'm going to get the same kind of pattern that I did previously. And then I have to ask myself, how many times does this happen? Well, I go from on the graph to above and below and back to on. That's 1. Above and below, that's 2. Above and below and back to 0, that's 3. Above and below, that's 4, that's 5. So I still have to go through 1, 2, 3, 4, 5 cycles. And again, that number 5 is happening in part because of the symmetry of this graph. So now I want to figure out what the equation of this graph is, and it looks to me like it's a sine graph. And I have 1, 2, I'm switching pens, that's why it's taking so long, 3, switching colors anyway, 4, 5 cycles of sine. So I have the sine of 5t. I decided my amplitude was 2. So the equation for my y graph, my white graph here, is the green graph plus how much above and below, how much I've added to the green graph to get the white graph. It's the green graph plus this other little graph. So plus 2 times the sine of 5t. Now, I happen to know that's not the right answer, and there are several clues that tell me that that's not the right answer. I'm not going to tell you right now what those are because I want to walk through how you graph this, how you check this answer, or how you're going to check it in the interface that we're going to be using. And then we'll talk about what adjustments you have to make. So what I'm going to do now is stop this video, and the next video will be on Desmos, and I will show you how to graph these equations, the equations that we came up with for what we think are the equations for this graph, and then how to adjust them so that they really are.